Mean, median, and mode, measures of center. Mean, median, mode are important tools in a statistician's toolbox. These measures of center all use data points to approximate and understand a middle value or average of a given data set. Two more measures of interest are the range and mid-range, which use the greatest and least values of the data set to help describe the spread of the data. So why would you need to find the middle of a data set? And why do you need three measures instead of just one? Let's look closely at these measures of center and learn how they can help us understand sets of data. Mean is a mathematical term for average, which you may already know. Also referred to as the arithmetic mean, it is found by adding together all the data values in a set and dividing that sum by the number of data items. You can also find the average of two familiar numbers such as 10 and 16 in your head without much calculation. What number lies halfway between them? 13. A mathematical way to solve this, though, is to add 10 and 16, which gives you 26, and then divide by 2, since there are two numbers in the data set. 26 divided by 2 equals 13. Knowing the process helps when you need to find the mean of more than two numbers. For example, if you're asked to find the mean of the numbers 2, 5, 3, 4, 5, and 5, first find the sum. 2 plus 5 plus 3 plus 4 plus 5 plus 5 equals 24. Then divide this sum by the number of numbers in the set, which is 6. So the mean of the data set is 24 divided by 6, or 4. In the previous data set, notice that the mean was 4, and that the set also contained a value of 4. This does not always occur. Look at the example that follows. The mean is 18, although 18 is not in the data set at all. Find the mean of the set 4, 7, 28, 33. First, add all the values. 4 plus 7 plus 28 plus 33 equals 72. Then divide by 4, or the number of the values. 72 divided by 4 is 18, so the mean is 18. Next, let's look at median. The median is the middle value when the data is ordered. If there are two middle values, the median is the average of the two middle values. To calculate the median, you first put your data into numerical order from least to greatest, then identify the middle value or values. For example, let's look at the following values: 4, 5, 1, 3, 2, 7, 6. To find the median of this set, you would put it in order from least to greatest. 1, 2, 3, 4, 5, 6, 7. Then identify the middle value. There are three values to the right of 4 and three values to the left of 4. The middle value is 4, so 4 is the median. If there's an even number of data items, however, the median will be the mean of the two center data items. Let's take a look at an example. Find the median of the set 2, 5, 3, 4, 5, and 5. First, arrange the values from least to greatest. 2, 3, 4, 5, 5, 5. The set has two middle values, so take the mean or average of the two values. 4 plus 5 is 9, over 2 gives us 4.5, so the median is 4.5. Finally, let's consider the mode. The mode is found by looking for the data values that appears most often. If there is a two-way tie for most often, the data is bimodal, and you use both data values as the modes. Sometimes there is no mode. This happens where there is no data value that occurs most often. In our example data set, 2, 3, 4, 5, 5, and 5, the number 5 appears 3 times, and all the other numbers appear once, so the mode is 5. Let's look at an example. Find the mode of the set 12, 4, 12, 5, 5, 8, 12, 0, 1, 12. First, arrange the values from least to greatest. Although this is not a necessary step, it sometimes helps to find the mode if the numbers are arranged in ascending order. Then find the value that occurs most often. In this case, the mode is 12. Let's look at an example with some relevant data. Carlos received the following scores on his mathematics exam: 84, 92, 74, 98, and 82. Find the mean, median, and mode of his scores. To find the mean, add all the test scores together and divide by the number of tests. The mean is 86. To find the median, order the test scores from least to greatest. There are 5 scores, so the middle test score is the third in the ordered list. This is the median, 84. Since each number appears exactly one time, there is no mode. So the mean is 86, the median is 84, and there is no mode. What can be learned from the mean, median, and mode of Carlos's test scores? Notice that these values are not the same. Both the mean and the median give us a picture of how Carlos is doing. Looking at these scores, you'll notice that the middle of the data set is in the mid-80s. The mean value is 86, and the median value is 84. That's all you are really after when using median and mean, finding the center or middle of the data. Notice also there's no mode, since Carlos did not score the same on 2 tests. In the case of test taking, the mode is often meaningless, unless there are a lot of zeros, which could mean that the student didn't do his homework or really doesn't know what's going on. Let's look at another example. Find the mean, median, and mode of the following set of numbers: 12, 11, 13, 11, 12, 10, 10, 11, 13, 14. To find the mean, add together all the numbers and divide that sum by the number of numbers. So 12 plus 11 plus 13 plus 11 plus 12 plus 10 plus 10 plus 11 plus 13 plus 14 divided by 10 numbers gives us 117 over 10, or 11.7. To find the mean, first order the numbers from least to greatest. Since there are 10 numbers, an even number, the median is the mean of the middle 2 numbers, the 5th and 6th, or halfway between 11 and 12. To find the mode, look for the number that appears most often. The number 11 appears most often, 3 times. So the mean is 11.7, the median is 11.5, and the mode is 11. In this case, the mean, median, mode are very close in value. This shows some consistency in the data, with a middle or average value about 11. If this data represented the ages of students on a chess team, for example, you would have a good idea that everyone on the team was about 11 years old, with a few older and younger members. Let's look at another example. During a 7-day period in July, a meteorologist recorded that the median daily high temperature was 91 degrees. Which of the following are true statements? 1. The high temperature was exactly 91 on each of the 7 days. 2. The high temperature was never lower than 92 degrees. 3. Half the high temperatures were above 91 degrees and half were below 91 degrees. A, 1 only, B, 2 only, C, 3 only, or D, 1, 2, and 3. A, 1 only, is incorrect. Just because the median high was 91 degrees does not mean that the temperature reached 91 degrees on each day. The correct answer is statement 3 only. B, 2 only, is incorrect. You know the median is 91 degrees, so 91 degrees is a member of the data set, meaning that the temperature had to have been lower than 92 degrees at least one time during the week. The correct answer is statement 3 only. C, 3 only, is correct. Half the high temperatures were above 91 degrees and half were below 91 degrees, since the median will always represent the value where half the data is higher and half the data is lower. D, 1, 2, and 3, is incorrect. Statement 1 is incorrect because the median high of 91 degrees does not necessarily mean that the temperature reached 91 degrees on each day. And 2 is incorrect because you know the median is 91 degrees. So 91 degrees is a member of the data set, meaning that the temperature had to have been lower than 92 degrees at least one time during the week. The correct answer is statement 3 only.